right. Good night. This is the 2025 additional math paper 2 exam solutions. So one of my students sent me this paper. She said she wanted me to do it. I said, you're very brave. She said, yes, sir. Let's see what I did. Right? It's Jaden free. So let's do this. All right, let us do this. 2025. Let's see what it is. Bam, 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 bam. First question. We have to solve this equation. Solve means we have to find the unknown, which is x right there. Given no answer in exact form, meaning no decimal, anything like the exact form. Now, when the thing that you're trying to find is in the power, you must take logs. Get it out of the power. You take logs on both sides. I'm going to take the log of the left side. So it's going to be the log of 3. 2x plus 1 becomes equal to the log of 21. And I'm not going to work this out because it said in exact form. Let's not work it out in. And what happens next is that this whole power comes to the front as a whole. Very important that it comes as a whole. So 2x plus 1 log of 3 equals the log of 21. Then we can divide by this log of 21, then subtract that 1, and then divide that 2. And write the final answer in one step. Well, let's go step by step. 2x plus 1 is going to be the log of 21 divided by the log of 3. Then we can transpose the 1 and then divide through by 2. So we're going to get that the x is equal to, it's going to be half of this. All right? It's going to be log of 21, half of the log of 21 over the log of 3. Let's write it like this. My brain is telling me to do something else with this number, using the change of base law, but that is not in odd maths. Right? So I'm not going to do it. But in a pure maths paper, I'll do this at different way. Then I would subtract the 1 and then divide by 2. So I'm subtracting half. That is the answer in the exact form. All right? That is the answer in the exact form. So I'm not going to change anything. Right? Exact form means I don't want any decimal or anything like that. So leaving it with the log expression like that. Then now down here says determine the value of x and y which satisfy the equation. So basically that's a simultaneous equation that we're solving. We can start by subtracting or we can substitute. All right. So this is equation 1. Let's name them. Or I can just use a substitution method and use this equation and write it y as a subject instead of part in red. So when I write this equation by transposing the 3x, right, that's y equals 2 minus 3x. I'm going to substitute for the y right here. Let's do it here. I'm going to say sub for y. What's going to happen is that I'm going to take this and replace the y that is right here. So we're going to get y, not y, we're going to get 2 minus 3x. That's 2 minus 3x for this y plus 4 equals, I'm going to expand this side out into a quadratic. So I'm going to get 5x minus 2x squared. It's a quadratic. Not a lot of space to work with, guys. So, right? So not a lot of space to work with. So maybe I need to do this part on the left over here. Over here. And then still say sub for y. Put the arrow pointing this way. Sub for y. That's what I'm doing here. Subbing for y. All right. So this 2x squared comes over onto this side to become a positive 2x squared. This 5x comes over here with that negative 3x and give me negative 8x. This 2 and this 4 is 6. That's all equal to 0. This can be divided through by 2. We're going to get x squared minus 4x plus 3 equals 0. This factorizes easy over the factors of 3 that add 4 is 1 and 3. And both brackets are going to have the same sign, which is negative. So we have x and x are factors of the x, 1 and 3. This says the two signs of the bracket are the same. They are both negative. Negative, negative equals 0. So this factor is going to give me, if that is equal to 0, then x is equal to 1. Let's write them up here, continue up here. So we're going to get x equals 1 point, x equals 3 at the other point. I want to sub into this to find the corresponding y value. So for this one, I can say and y is equal to 2 minus 3 times 1 on this side, which gives us y equals, that becomes a negative 1. And this one, we're going to say and substitute here again. It will be y equals 2 minus 3 times 3. That's subtracting 9. So y is negative 7. And it also said what is of x and y. So here would be solution. We're to write a solution. It will be x equals 1, y equals minus 1. That's one pair. I could write as a point like this, 1, negative 1. The other one is 3, x equals 3, y equals negative 7. And that would be, or that could be 3, negative 7. All right, and it's not like this sometimes, because you can, I like to test the answers to see, if the points will work. So this is this other equation. So y plus 1 this side, by using here, this side would have been 3. And this side, if I put the 1 on this side, it would also be 3. So I trust that answer. All right, I won't bother checking them. I'd say confident. I'm going to try the 3. So here, on this side, y is negative 7. So that will be a negative 3. This side would be 3 times, that would be 5 minus 6, 3 times 1, right? So that's a negative 6. 5 minus 6 are negative 1, right? So that's negative 3. So I just check that those answers are correct, right? So these answers are. Let's continue. That's just a simultaneous equation. A rational inequality. Determine the solution set for this inequality, giving your answer. Set with the notation. Now, the important thing to note about this one, because of this equal and the inequality, you must know that the denominator, x minus 1, cannot be equal to 0. So x cannot be equal to 1. Right? That must be understood because we cannot divide by 0. So we cannot accept a solution that is giving us x equals 1. What's going to happen here still is that we're going to solve this the normal way, which is to multiply both sides by the square of the denominator. Let's write that. Multiply both sides by x minus 1 squared. And this then show that we're multiplying with a positive value because we're doing an inequality. And when you multiply inequality with a negative number, you have to reverse the sign. Another way to look at it is that if the quotient of two numbers is less than 0, meaning negative, then the product of the same two numbers is less than 0. So that's another way to look at it. In any case, what we're going to get is that x minus 1 times x plus 2 is also less than or equal to 0. But what we know is that this is going to produce a small shape quadratic curve to expand. The square term is going to be positive. So this inequality is related to a small shape quadratic. I'm using the sketch method. Just did a couple questions with this with my students the other day. They were using trial and error method. All right. And as I said, the values, the root from this factor will be negative 2 over 3 inclusive. So I'm putting a shaded circle here, negative 2 over 3. And the root from this factor will be 1. But I'm putting an unshaded circle here. Put across, and remember the x cannot be 1 up here. The x cannot be 1. That's why I'm putting an unshaded circle on the 1. Say I cannot 1. 1 is not a valid value. Then the part of the graph that is less than 0 below the x-axis under here, those are where function values are less than 0. Those are obtained by values that are between these two values. So your x is supposed to be between those two values. That is, your x has to be less than 1, not equal. Remember, can I put the equal on the 1? But greater than or equal to this value of negative 2/3. And this is your solution. But it's a set builder notation. So because of that, we're gonna write like this. Our solution is gonna be set brackets. You can say x is such that, and let's write about this inequality. X is such that it is between negative 2/3 and 1, inclusive of the 2/3, but not inclusive of the 1. Remember, you cannot put the equal on the 1, and that is given from here. So we're gonna put minus 2/3, minus 2/3 is less than or equal to x. Then x is less than 1. That's your set builder solution. All right, that is that. Next part says, state how solution of this would differ from this. I think what it is that in this one, the denominator cannot be 0. So the solution from this one, right, would include both values. Solution for this one, right, would simply be that x is less than or equal to 1 because it's okay to include the 1. Greater than or equal to negative 2/3. So the difference is that the 1 is included. All right. So I would say the difference is that x can be equal to 1. X can be equal to 1. X is equal to 1 in this one, in 3x plus 2 x minus 1 less than or equal to 0. That is the difference. So we're including the 1 on this one. One mark for stating that. All right, this is something that I pointed out to my students just the other day. They remember. All right, a couple of them in particular. All right, so this now we're asked relationship between two variables x and y. This, and we have to express that relationship in this form, which is a linear form. All right, so basically it's to just basically get the indices out of it. So what I'm gonna do is multiply mean that you're gonna add the powers. So this expression firstly is 10 to the 2x plus y to the 2x plus y equals 3. Then to get the logs out, to get that expression out of the power, to get like that, we have to take logs of both sides. I'm gonna just log this side in red and log this side in red. So take a log of both sides. Then this whole power comes to the front. So we end up getting 2x plus y as a whole and the log of 10. By the way, this LG means log to base 10, right? Same thing up here. LG means log to base 10. I did it the first time. That's right. This LG means log to base 10. All right, that is understood. of the base 10. Right. So here now, this expression becomes this. This side remains log of 3. All right. I'm going to divide by this log of 10 and then make y the subject. That's what I have here. All right. So I'm going to get, I'll do it in one step. Make y the subject. Yes, we can. Divide by this first and then transpose this to x. So I'm going to get y equals log of 3. Oh, but log of 10 is 1. Wow, log of 10 is 1. So log of 10 is just 1. All right, so this is just equal to 1. That's log of 10. So that is 1. All right, so this is just 1. And so I'm not really left with this. I'm really left with 2x plus y equals the log of 3. So I can just transpose it to x now. And so y becomes the log of 3 minus 2x. Let's say express this in this form, which we have done, right? This the same looking at that. If you want to state the values, wanted to state the values, then from this, the b would be 3, and the plus a would be negative 2. So we can write a equals negative 2, b equals 3. Prefer to compare, but I think if they just leave in that, that will be fine. That will be the answer. I'm writing it in the form y equals mx plus c with this. Y equals mx plus c would be y equals minus 2x plus the log of 3. So then this will be a gradient, and this will be a y-axis intercept. If you draw a graph of y against x, y against x. Here it says hence, or they're asking you that now. Hence, state the value of the y-intercept. State the value of the y-intercept on the graph of y versus x. It is this log of 3. Log of 3. That's the value. That's what the coordinates you would put this 0 log of 3. But all I wanted was the value, and you're stating it, right? No calculation, it's just this value. Okay, right. The C value, which is equal to that. It's actually the C value. All right. This is what this is. So that's the answer. Log of 3. All right. Next part says determine whether this is arithmetic or geometric. So if it's arithmetic, there's a common difference. You're looking for a common difference. And if it is this one, it will have a common ratio. So it's like this common difference. This one has a common difference. And this one has a common ratio. Which is a common multiplying constant, right? Common difference is what it says, constant difference. All right, so this series, it actually has a common ratio, because from here to here, if you're using a difference, that's a plus 4, but then from here to here is a plus 12. So clearly it's not a common difference. It's a common ratio. What's a common ratio? We keep multiplying by 3. And set up like this. It is 2 plus 2 times 3. So we got the 6 plus 2 times, and multiply by 3 again. You get 3 squared, which is 9, which is equal to that. Then you continue. 2 times 3 cubed. 3 cubed is 27 times 2 is 54. And then this 2 times 3 to the 4th power, and so on. So there exists a common ratio. So I'm going to say common ratio is 3. Because it's a common ratio, it's a GP. Therefore, series is geometric. All right, because it's a common ratio. So we have taken the series and form of a geometric series. All right, that is it. No, 2 marks for that. That's part 6. In a geometric series now, in a geometric progression now, so the third term is 25. The third term is AR squared. Remember the nth term, it's right up here. Nth term for GP is AR to the n minus 1. So the third term is 25. That means that AR squared is 25. And the sum of this first and the second term is 500. Now, first term is A, the second term is AR. It's telling us that that is equal to 500. They're asking us to find a common ratio greater than 0. Right? Find a common ratio where common ratio R which is greater than 0. So I always tell students, when you get simultaneous equation, you sort thing from a geometric series, you normally divide, you solve by dividing. So all you need to do is divide these two. So I'm going to divide this one by this one. I'm going to divide them. So I'm writing it here. Write it here that I'm dividing. Solve simultaneous equations from a GP most time by dividing. From the AP, you solve them by adding or subtracting. So I divide one by the other. I'm going to put this one over this one. Right? So I'm going to put A plus AR over AR squared, and then put 500 over the 25. 500 over 25. All right. So we're going to do all right, 520. Then now the A's here will cancel, right? When we cancel the A's, this thing reduces to, it becomes 1 plus R over R squared. And this becomes 20 plus 20. That's what we're solving now. Let me put it over to the left. So this equation became this. Now they really don't give a lot of space to work. So this equation became that. And if I were to continue, maybe I'm writing too large. Right? If I were to make this a little smaller. So it's a little smaller. Right, I'm solving this now. Multiply by the R squared over here. I'm gonna get 0. I'm gonna transpose it. I'm gonna get 0 equals 20R squared minus R minus 1. And this factorize, I'm gonna factorize this side. So 0 becomes equal to 4R and 5R, 1 and R, 1 and 1, 1 and 1. This says sides are different. So the greater product, the minus. The greater product is a near one. Make that one negative. Make this one positive. Those are the two factors. Because this time this gives me the 20R squared. This time this gives me the minus 1. The middle term is the sum of the far product, which is 4R, and the near product minus R. So from this, I'm getting R equals quarter, or of this I'm getting R equals minus 1 over 5. But this one is not valid because they told us here that the R is positive. So this one is not valid. Not valid. Therefore, this one is the answer. This is our answer right here. Plus R is greater than 0. Plus R is greater than 0. That's right. So no answer. R is equal to a quarter. Done. Next question says kitchen garden. Kitchen garden has an area of this. That's the area. So the length of the garden is that. Determine the value of A if the width of a garden is this. All right, so what do we know? We know that the length times the width is equal to the area. That's what we know. I'll put another way. Area is going to be, no, the area divided by the length is equal to the width. Multiple ways to do it. I'm going to multiply them. This times this equals that, right? Length times width equals area. I'm going to say the width times the length is equal to the area. So it is A plus root 5 times this one. Easy to divide them, you know. It's easy to divide this by this. It's in this form, and I will see what the A is, you know. It's easier that way. Rather than multiply and expand it. So let's see. You multiply that now by the length, which is 5 minus 2 root 5. That's all equal to 10 minus 3 root 5. I think there's more work than needed. So I will try to do it the easy way. This time this is 5A. And this time this is plus minus. I'm doing the other way. I will divide. Dividing is easier. Minus 2A root 5. And then this time this is plus 5 root 5. And this time this root 5 times root 5 is 5 times this 2 is 10. That's minus 10. That's equal to 10 minus 3 root 5. Working out enough. Right? That's a minus 10. Too much work. Too much work doing it this way, guys. Too much work. 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 Too much work doing it this way. Too much work. Too much work. So this gives me 20. When I take this 10 over, and this comes over to minus 8 root 5. And that is 5A minus 2A root 5. After it is a 2, how can I integrate the parts, right? You have the third part and the rational part. The irrational part and the rational part. So it's 5A minus 2A root 5. So we can say 5A equals 20. Aha! 5A equals 20. So A equals 4. So it works this way as well. Or you could say this 2A equals 8 to compare that. 2A equals 8. So A equals 4. Let me look at it, A equals 4. But I feel like I want to do this another way by dividing and see what I'm doing in purple. But it's smaller first. So that method that I use that first. The other method is to divide. Came to my mind. I'm going to do it this way. Do or, draw a line through here on the or, we could say the width, this width is equal to the area divided by the length, right? We say the width is equal to the area divided by the length. And the area is this thing up here, 10 minus 3 root 5 over No, let's write it out like so. The width, which is this, a plus root 5, a plus root 5, a plus root 5 will be equal to 10 minus 3 root 5 divided by this length. This is 5 minus 2 root 5. Now what happens now? Make it smaller. Space to work. Oh, actually. And then now what would happen is that we want to basically rationalize this denominator to get the expression looking like that. So to do that, we multiply numerator and denominator by the conjugate of this. So the first way is for real. So it's times 5 plus 2 root 5, 5 plus 2 root 5 to rationalize this denominator. Right? So this then become 5 times 10 times 5 is 50. 10 times this is 20 root 5, so it's plus 20 root 5. Then minus 3 root 5 times 5 is 15 minus 15 root 5. Careful now, this times this. Remember that the root 5 times root 5 is 5. 3 times 2 is 6. So 6 times 5 is 30. That's minus 30. Divided by then this times this is the difference of 2 squares. So it becomes 5 squared, which is 25, minus this squared. Now we square this right away. So the squared is 2 root 5 squared would be 4 times 5, right? Which is equal to 20. So here we subtract 20. So maybe the first way is for real. I use a 5. Then this reduces to what now? Let's see. This one I use a 5, and remember. So this and this give me 20. And 20 divided by this 5 is 4. This and this is what? That and that is 5 root 5 divided by this 5 is root 5. So I'm getting up plus root 5. There you have it. This A is equal to 4. First method might have been easier. Right, therefore, A equals 4. Whichever way you did it, you get the same result. All right, let's continue. One more equal better math. Equal better math every time. This question says, using the grid on page 11, draw the graph of sine of 2x and the cos of 2x. 0 and 5. Now, the sine of 2x, I'm just going to call this sine of 2x between 0 and 2 pi means that you have two full sine graphs between 0 and 2 pi. Sine graph starts at origin. That's 1. It's 1. Second one. 2 pi will be out here. So you have two full cycles between 0 and 2 pi for the sine of 2x. And therefore, because all 1, 0 to pi, it means that this is the graph that we have to draw. Draw it up here. So we get one cycle of the pi. Same thing happens with the cosine graph. And I put the cosine graph on this sketch. Just to illustrate. Cosine graph on this sketch, the cosine graph will start up at 1. Right? I'll start up at 1. Come down here, turn up here, and end up here. It's 1. And then it will continue. Turn it to here, end up there. That will be the cosine graph cos 2x. It should be cos 2x. So this down here will be sine 2x. I'm just sketching it for you. And this up here will be cos 2x. Because of the 2x, you have two full sine cycles between 0 and 2 pi. You have to with a cos. right? But the question only wants up to pi, so it really only wants this. So when you finish drawing a graph, you're supposed to only get what I have in the red box. All right. And it says here, hence or otherwise, we have to solve this equation. That's where the sine 2x equals cos 2x in the region. So it's talking about these 2 points where they intersect. It says hence or otherwise. So the hence means that we're using the graph, but otherwise means that you could actually use a calculation method. All right. So that's what we're gonna do. But we have to do it on the graph. So how we're doing it on the graph, it has to be accurate. And we're gonna say on a graph. And there's a graph. Let's do one in purple and one in blue, just as I have here. Let's do the purple for the sine 2x. All right, so the sine 2x starts with origin, sine of, we're doing sine of 2x. So sine of twice, whatever that's what it is. Now, pi by 4 is 45 degrees. So then 45 degrees is 90. Sine of 90 is 1. So it turns up here. Sine graph. Then now the sine of sine pi by 2. 2 times pi by 2 is pi. So the sine of pi is 0. So it passes through here, sine graph. Then now the sine of 3 pi by 2, where actually 2 times that becomes 3 pi by 2, which gives us 3 pi by 2, 3 pi by 2, that's 3 times 9, that's 270, sine of 270 degrees, negative. Now you can do all these with the calculator. And the sine of pi is 0. So those are points that the graph would pass through right there. So you're drawing a smooth curve through those points. Something looking like that. A cost graph is passing through similar points with similar values. There's a shift. Let's do that one in blue. So if we're doing a cost graph now in blue, cos of 2x, similarity. The cos of 0 is 1. So it starts up here. Then now, for pi by 4, 2x, 2 times pi by 4 is pi by 2. 2 times pi by 4 is pi by 2, which is 9 degrees. The cos of 90 degrees is 0, so it passes through here. Then this is pi by 2. 2 times pi by 2 is pi. The cos of pi is negative 1, so it turns down here. Then again, passes through here again, similarly. And then now, this is pi, this is 2 pi. Cos of 2 pi is 1, just as the cos of 0 is 1, so it comes back up to here. So the cosine graph is passing through those points. That's the turning point down here. So if you go like this, something like this. Turns down there, goes back up through here, and it goes like that. These two graphs kind of similar, they have the same shape, just that they are shifted from each other a bit. They're shifted from each other by pi by 2. If we shift this, well, actually pi by 4, if we shift this graph, this blue graph a little bit to the right, it will then coincide with that one, all right? It's a relationship between them. Then the question, after that's the sketch of graph, let's label it up. This one is a cos 2x. Let's label it up, cos 2x. So I will label your graph. This one is cos of 2x. Cos of 2x, this one. Cos of 2x. And the purple one is sine of 2x. Sine of 2x. Alright, sine of 2x and cos of 2x. Those are two graphs. And here it says, let's take this out. Here it says, hence, or other, we're going to use our hence method first. So the hence method is the graph. find the equation. So this means where they intersect, right? Points of intersection on the graph. So intersection on the graph. That's when they're equal. Intersection. And you now send answers in terms of intersection. The graph. Of the graphs. Intersection of the graphs. Let's see where they intersect, right? Alright, so my two graphs similar. So here they're intersecting halfway between 0 and pi. And remember, I told you that the graph is a phase shift of this distance. And here they cross each other halfway, which is halfway between 0 and pi by 4. That is pi by 8. 0 plus pi by 4 by 2. That's pi by 8. This is pi by 8. And they also intersect here, which is right in between pi by 2 and 3 pi by 4. So that's pi by 2 plus 3 pi by 4. And dividing that by 2. So divide this one by the 2, get 1 here. Divide this one by the 2, get 8 on the here. So here now I can multiply this one by 2 over 200, that over 8, and 2 and 2 and 3 is 5. So that's 5 pi by 8. So right here, 5 pi by 8 for the intercept. Halfway between these two values. 5 pi by 8. That's what the intersect on the graph. Here, with the mark on the graph, here it would be, did I say pi by 8? X equals pi by 8. X equals 5 pi by 8. Yeah, this is the ends method. Use the graph. You could just read those off, right? You have to know that it's halfway between those values. The otherwise method in blue. Solving a simple equation that with sin and cos in it. You divide by the cos and form tan. Right? Now you know. Then sin and cos equal these two angles is 45 degrees with the equal. Right? So it means that 2x would be pi by 4. Right? 2x would be 45 degrees, which is pi by 4. The other angle would be second quadrant here. Where sine is positive, treat the sine as the subject function. So it's positive here and here. So it will be pi by 4. This quadrant would be pi minus pi by 4. Let's see that away. So if I'm going to solve it, I'm going to say I'm solving sine 2x equals cos 2x. I want to divide both sides by cos 2x. So I get tan of 2x equals 1. And from this we can draw the quadrant diagram. The quadrant diagram where tan is positive. That's here and there. And the principal angle for the 1, that the alpha is tan to the minus 1 of 1, which is 45 degrees, or pi by 4. So then 2x, this quadrant would be the same pi by 4. But in this quadrant, it will be pi plus. So getting the wrong answer a while ago. So it will be pi plus pi by 4 in this quadrant. And this pi plus pi by 4 is 5 pi by 4. And now we divide by this 2 to get the x. So the x would be, for this one is pi by 8. And then this one, because this one is 5 pi by 4 divided by this 2, I'm going to do 5 pi by 8. Those are the two bases to be answered by the otherwise outline. Alright, analyze why I was the answers wrong. That we analyze as cost. Sin and cos is the same. Then another time, this is a better solution. We make an equation with sin and cos in it alone. We divide by the cos form tan. Right? So it's done. I'm not discussing that now. Next one. It says using an appropriate double angle, derive and identify the sine of 2x. You know that this should be double angle. Because I want to prove a double angle. So this word should have been compound angle. Again, a mistake right here. Here they should have said compound angle. Prove the double angle. Compound angle to prove this double angle is sine compound angle, which will be on the formula sheet, which is what did they put on the formula sheet? Formula sheet, we call it MB. It's always M. Yes, there. Sine of A, sine of B, which you should know. Sine, cos, sine. Right, more things in on the better. So we're using compound angles. Sine of A plus B is equal to sine A cos B plus cos A sine B. That's what it is. But here now we're going to make the x, to get the 2x, we're going to make the A and the B equal x, right? So we're going to put A equal B equal x. That's what we're going to put. This becomes the sine of 2x, because A and the B equal x, so that is 2x. And then now, each of these is an x, right? So we get the sine of x, cos of x, plus cos of x, sine of x. But note that this and this is the same term, because if you look at this other way, sine x cos x, sine x cos x. So this therefore is equal to 2 sine x cos x. That's what the sine of 2x is equal to. We should actually go in the exam armed with the knowledge of this, know it, and also know that that is how you derive it from the compound angle. All right, you should go in the exam knowing these things. Not going to the exam to figure this out. It's not a figure out question in the exam. This is a know it question in the exam. More things you know, the better. You have to figure out stuff. This one says, hence, prove this, that this is equal to that. All right, so to give us a double angle here, so we're going to write it out as that. All right, and then it must all come down to this. So there are multiple ways to do it. Because I have a sine x cos x up here, the classic way to do it is to take this expression. And because I said hence, I'm going to expand this out to that. But what I'm going to also do is multiply numerator and denominator by this, the result that we want. So I'm going to write the left hand side equals 1 plus, and then this now I'm going to write what it is in this form, expanded form, percent. Let's say hence, which is 2 sine x cos x divided by this sine x plus cos x. Now look at this result. I need it like over 1, right? I need it on the numerator. So what I'm going to do to force it is to simply multiply this thing by the same thing, sine x plus cos x over sine x plus cos x. And work out itself for sure. So what's gonna happen now is that, remember now I want this to be my answer, so I'm not gonna touch it. I'm gonna leave it. I'm gonna leave that because I want it to be my answer. So it means that it's gonna be my answer. So everything else here is supposed to work out to be equal to 1. That is like over 1, right? So everything there is supposed to work out to 1. Because this is going to be my answer. That's the approach I'm using. There are multiple ways to do it, but this is the approach I'm using. So I'm going to be focusing on this, adjusting this, and leave this, leave that, because that's what I want in the answer. All right, so let's put these two together first and leave this as this for now. So I'm going to have 1 plus 2 sin x cos x, and I'm leaving this up here because I want that to be my answer. Sin x plus cos x, shift this all over. So sin x plus cos x, and I'm putting that over. I'm going to multiply this time. Now that's a perfect square, right? This time this is a perfect square of that. So it becomes the first term squared, which is sin squared x plus twice product with 2, which is 2 sin x cos x. And the second term squared is cos squared x. And I'm seeing it now because sin squared plus cos squared is equal to this 1. And this expression is the same thing that we have here. But if you have to change the double angle, I could recognize it from this. But I guess the inspector thing does the same. This really becomes, you can see a line, you know, because this really cancels with this, you know, because they're the same. But maybe I guess I need to show it. To show that this is equal to 1. Right? So it becomes 1 plus 2 sin x cos x times the sin x plus cos x divided by all of this now becomes another 1 plus 2 sin x cos x. Why is that? Because the sin squared plus cos squared is equal to this 1. Right? That's what out here. These two things cancel each other. This and this cancel each other. So we are left with this. I don't like to cross out stuff on the paper. Right, so stuff like that. That's underline. This and this is the same. We can see it up and this cancels with that. You know, different color side will show. And so I'm just left with this thing, which is the right hand side, equals sin x plus cos x, which is the right hand side. For sure, you know, I feel like the one on the prayer must be, but this was easier than this. I know this is difficult, but I just feel like the one on the prayer must be, but this here was easier than this, the proof, which we prove. It's easier than this. I just feel like the one on the prayer must paper could situate more quickly. That's what I remember. This one says the quotient vector of A and B are these. Now, this is what, if that is the point A, whose coordinates relative to O. Quotient vector of two points A and B whose coordinates are relative to O. Quotient vector of 2 points A and B whose coordinates are that and that respectively are relative to an origin O. So it means that OA will have the same values of this in the vector form, 2, 3. And OB will have the same values as this one, minus 3, 2 in the vector form. And I want us to find the vector AB. Easy. Vector AB is equal to OB minus OA. Easier than CSEC general. So doing this one minus this one. Careful now. So it's this value minus this value. It is negative 5. Let's try it out. Minus 3, 2 minus 2, 3. This becomes this minus 2 is negative 5. And then 2 minus 3 is negative 1. So negative 5, negative 1. All right, let's grab this. Sharing purposes. All right, that's OB minus OA. part says find the angle AO. So it's like you have O is the point in the middle. So like you have A to O to be like this. This is O, this is A, this is B. So using OA and OB, two divergent vectors. Find the angle theta and here one is called theta. And finally the angle. Now remember now, the angle theta is cos to the minus 1 of the scalar product. I'm just going to call it A dot B over the modulus product, modulus of A and modulus of B. And what I'm doing, I'm making the A equals the vector OA and B is the vector OB, just for simplicity. So then the scalar product over the modulus product. What's the scalar product? So these two vectors here. And I just copy these down. So in front of us on the screen. Yes, you know. So I'm shifting out a little bit. So shift all of this over to the right. A bit more. Put this more here. And let's do it a different color. Do it red. All right. Now that's all in front of us. We can say theta equals cos to the minus 1 of the scalar product. Now these two, we multiply these two values first. A negative 6. And then multiply these two values, 3 times 2, that's 6. That's a 0 now. It's a 0 in the numerator. So the angle is 90 degrees. I'm just gonna put in these values, just putting them in C because this becomes a 0, scalar product is 0. So it's gonna become square root of 2 squared and 3 squared. 2 squared and 3 squared. I don't need to put in these values at all. I don't know 0 already. 3 squared and 2 squared again. 3 squared, 2 squared. And this up here becomes 0. So it's constant minus 1 of 0, which is 90 degrees. Constant minus 1 of 0, which is 90 degrees. All right. It says since the relationship between them, the angle between them is 90 degrees, they are perpendicular. And that's what they are. They are 90 degrees to each other. That right angles. Relationship between two vectors. The scalar product is 0. The scalar product is 0. So they are 90 degrees. Cos minus 1 of 0. 90 degrees. Cos minus 1 of 0 is 90 degrees. That is it. Done. Number 4. 6% on this paper and so on halfway. So I said differentiate the following expression of just the x. So this now first I'm going to write this as a power function. I'm going to write this as y equals so sine of 4x plus 3x to the minus 4. So I'm going to differentiate it now. dy by dx equals, and differentiate sine, I get cos. You have to differentiate the 4x first and get 4. So it becomes 4 cos 4x. We differentiate this and multiply by the power. We're going to get minus 12 times x to the minus 5. That is it, about question says simplify. So because it's simple, I'm going to give them back in a form looking like that. So this smaller a little bit. You talk in a form looking like that. Let's say this becomes 4 cos 4x minus, right, this has 12 over x to the 5th. That is the answer. Right there. All right, differentiate sine, get cos. We have 1 by differential of 4, which is 4. And then 4 choose 12. 12. All right, that is it. Next part says determine the coordinates of the stationary points. Remember, the stationary points, dy by dx is equal to 0. All right, so I'll differentiate this and put 2 for 0. So the dy by dx on this function is equal to the zoom up. This one is a cube. Compared by the cube, we can get cancel. We're going to get x squared root is 4 by 1 to x squared. So we want to differentiate that. We'll differentiate with this 2 multiplied by 2, cancels this 2, and we're going to get 5x. So we're going to get 5x. That's 5x. Differentiate this one, get plus 4. And that's all equal to 0 at the stationary point. So really now solving this two, which is a quadratic, factorizes out into x factors of 4 that add to 5 is 1 and 4. Those are the same, they are both negative. So 0. So we think x equals 1 or x equals 4. But the question said the coordinates. So I have to now find a y value to go with this and a y value to go with that by substituting them back into that function up there. Find the corresponding y value. I want to give it a space. So this one is giving me, when I put a 1 in here and here and here, I'm gonna get y equals third minus 5 over 2 plus 4 minus half. That's what I get when I plug 1 in this. I'm just going to use capital for this one. I'm going to get y equals, I'm doing 4 cubed. 4 cubed is 64. I can put a third 4 cubed minus 5 over 2 4 squared plus 4 times 4 minus half, and then use the calculator. Simple. Just 4 cubed. Let's put them in the calculator. Let's get a calculator. Faster. Can use it. Why not use it? Why not use it? Just this one first. So we're getting a third. Then we're subtracting 5 over 2. And then we're adding 4. Then we're subtracting 2. 1.3334 over 3. So y here equals over 3. So getting 1.1 over 3 is 1 point. That's an answer right now. That's 1 point. The other point within the x equals 4 here. Let's put this in the calculator. So this is 1/3 times 4 cubed minus 5 over 2 times 4 squared plus this 4 for 60. I'm just going to write 60. And then subtract this half again. Subtract half. And I'm getting minus 19 over 6. So y equals 6. So second point is 4 minus 19 over 6. That's the second point. This is by the two stationary points, right? Those are two stationary points. So this one is going to be the maximum. See, that's a higher value than this one. This is going to be the max. This is going to be the mean. All right? That's just a cubic function. Cube term positive is shaped like that. Maximum comes before the minimum. So the must measure the x value is less than that one. You can know these things before you even start, but you just have to still do it. You can just write the answer. But if you couldn't work this out, you could write the answer. Get a mark, minimum marks or 3 marks. You want it to do. So determine the nature each one. So determine the nature when you second derivative. It's calculation method, but we could actually just figure it out by looking at those points. So to get the nature, we need the second derivative. So one have to differentiate this again. Differentiate over here. Front of us. And write e2y by dx squared for the nature is equal to 2x minus 5. Differentiate this to get 2x. Differentiate this to get minus 5. Differentiate 4 get 0. So this is my dy by dx now. Put it in a box. Don't need it on this page. But let's calculate now. Place it down here. This is for the nature. To tell us the nature. This tells us the nature. So the first one is going to be a max. We'll see that work it out at x equals 1. Going to x equals 1. Remember it was 4, 1 and 4, right? It's 1 and 4. X equals 1 e2y by dx squared. If x equals 1 right here, it's going to be equal to negative 3. So less than 0. This gives us a max. All right. So therefore, we can write the 1 the max, right? 1, 4, 3 the max. 1, 4, 3 is maximum. Then now at the x equals 4, e2y by dx squared becomes, within 4 here, from the positive 3 to 48, and from the positive 3 greater than 0. So we can say therefore that point, which is 4 what again? 4 negative 19 over 6. 4 negative 19 over 6 is minimum. That is it. That is it. All right, next part. This part says the length of the edge of a cube is increasing at a rate of 0.2 centimeters per second. And that's the rate of change of the length of a cube. So like I have a cube like this. Let's sketch out one quickly. And I still know how to do this. Yes, I do. Cube looks like that. Then this blue pen lines inside here. All right, I want to make the length of a cube x. It's x all around, right? All right, so that is the rate this change. Basically, then it means that dx by dt, the change rate of change of the length is in time, and x is the length. Dx by dt is 0.02. So 0.25, that might say 0.25. It says calculate the rate of change of the volume. So this is asking us for dv by dt. That's what this wants. Right, so this wants dv by dt. All right, we're gonna have to connect the rates of change that we have. And we should be the volume of the x, that volume of a cube is x cubed. So volume is x cubed. So dv by dx is equal to 3x squared. Why did I do? Because I want to collect these rates of change, those two to get this one. All right, so what I need them. So when I set up this thing that I want to say now, the dv by dt that we want, out of a formula connecting b to t, we're going to have to connect the rates of change that we have. Becomes the product of two rates of change. dv goes on top of the first one here. dt goes on the bottom of the second one over here. That's also going to change. The third variable is x. So the x goes here, put that different color, and here. Now this is just that they gave us. And this one over here. And I want all of that when the length is 8. So I want it when x equals 8. So I'm gonna write it now. So this becomes equal to 3x squared times 0.25. And that's dv by dt. And then now when x is 8, so I don't want, right? It's important. X is 8. The dv by dt becomes 3 times 8 squared times 0.25. That is 64. 1/4 of 64, 16. 16 times 3 is 48. Let's see if that is correct. Let's see if my little math is good. Let's see, I'm gonna close the calculator accidentally. Let's get it. Close the calculator accidentally, guys. Let's calculate more. So I'm saying it is 3 times 8 squared times 0.25. 48, correct. So this is equal to 48. I have to say the volume is in the same cube. And time is in seconds. I did say per second right here. And so when I go write same cube per second right now. That's the answer. That is the answer. That one. Number 5. Drawing close. You know what to make this. I want us to integrate this. I'm going to write this as equal to the integral of 2x plus 1 to the half dx. All right, so it's going to be integrate the whole thing first. You add 1 to this power, get 3 over 2, so it becomes 2x plus 1 to the 3 over 2. You divide by the new power, 3 over 2. You also divide by the differential of what's in the extra quantum, which is this 2 right here. And don't forget the plus c, but there was no limit in the integral. Then we can reduce this because this 2 cancels this 2. So if the third of this, I have to write it back as a square root. This under here means square root, and this 3 means 4. You can literally write this as 1/3 square root of 2x plus 1 cubed plus c. Maybe if you left this, they give you a answers. So I was going to simplify. Why is this 1/3? Because this 2 cancels this. I put this 3 divided here, which is a third. This under here means square root. This 3 and then plus 4. That is it. Next one. Integrate sine and cos. Remember how you differentiate, all right? So this is just simply equal to, now remember now, that when you differentiate cos, you get minus sine. Cos x gives you, let's write it out. Let's write it out over here for you. Cos x, differentiate it, you're gonna get minus sine x. So if you integrate sine x, you're gonna get a minus sine. Then now when you differentiate sine x, you get in cos x. So when you integrate cos x, you're gonna get back sine x. So where do you know? So integrating sine to want to get back minus cos, because it's cos that gives you minus sine. We have to divide by the differential of this two, because doing the reverse process of differentiation, right? It's going to become equal to process. I'm going to get minus cos 2x. You divide that by the 2, which is the differential of the 2x is this 2. And I'm not sure you can differentiate this again, and you get that. Differentiate cos get minus sine. You have to multiply by the differential of the 2x, which is this 2. Then now when I differentiate sine, I get this cos. So if I integrate this cos, I'm just going to get back sine. So this part of it just becomes plus 5 sine x. Don't forget your plus c. That's the answer. It's not different color. This is it. Nice and easy. So that nice easy paper so far. Part B says figure 1 shows the region included between the x-axis, y-axis. Figure y equals x squared plus 2, and the line x equals 3. It's that region. So here is 0. Y-axis is x equals 0. This is where x equals 0. And this line is where x equals 3, right? This line is x equals 0. The y-axis is about this curve. X equals 0. This one is x equals 3. Bones and region, right? This one says calculate the area. Remember, area is integral of y dx. Area is integral of y dx, where y is the region of curve between the two limits. In this case, the limits are 0 and 3. And the curve y is this thing, x squared plus 2. All right, so if we're doing this, the area that I want becomes integral 0 and 3. The y is x squared plus 2. Don't forget to integrate with respect to x. So I'll put the x on this. So I will integrate with respect to something. X squared plus 2. Then we're good to go. So integrate that first, we get x cubed over 3. We get this 2, we get 2x. Integrating between the limits of 3 and 0. But this 0 is going to give us 0 everywhere. So the answer really is only with the 3. So that becomes equal. Let me shift this up. Shift this up. Let's change the color of this one. This one. Change the color of the purple. That shift it over as well. All right, let's make the circle smaller for this one. All right, so we're gonna put in the limits now. So it's gonna become that's 3 cubed over 3 plus 2 times 3. So when I put this 3 in here and here. All right, I'm going to subtract this 0. When I put in this, I'm going to get in 0. I'm going to subtract the 0. Let's work this out. Now, this is 3 cubed over 3, which becomes 9. It becomes 9 and 6 and 15. 15 units squared, I'm getting. 15 units squared. All right. 15 units squared. Next one. This one says the figure 2 shows share region enclosed between x-axis, y-axis, and a curve y equals 4 minus x squared. That's this one. It says if the region is rotated about the x-axis, one computer will calculate the volume. Now volume is pi times the integral of y squared dx when you revolve around the x-axis between the limits of a and b. So using this now for this one. Change the color for that one to red. That is it. So the volume required now, using that concept, we're going to have to square this now, which is 4. We're going to have to square this and expand it out into separate terms. All right. So the volume that we want must be so the volume that we want down here comes pi times the integral of 4 minus n squared dx between 0 and 2. 0 and 2 on the left curve. And we're going to have to expand this out. So it is pi times the integral 0 to 2. First term squared is 16. Twice product of the 2 multiply this and you get minus 4x squared, double that to minus 8x squared. And this term squared is x to the 4th power. And we're integrating with respect to x. Alright, we're going to integrate now. So pi into integral of 16 is 16x. So have this one is add 1 to the power, get 8x cubed over 3. With this one, we're going to get x to the 5th power over 5 between 2 and 0. Now what's going to happen here? This 0 is going to give us 0 everywhere. So it is really the 2 that's going to give us our final answer. So I want to leave it in terms of pi into 16 times 2 on this one minus 8 times 2 cubed over 3 on this one plus 2 to the 5th power over 5. When you apply the 0, one will subtract that 0 here. And let's put all of this in the calculator. The answer in terms of pi units cubed. So let's just put this in the calculator. Here. 16 times 2 right is 32. 32 minus, now this is 8 times 8, we do with 8 over 3, that's 64. That's 64 over 3. And then we're adding 2 to the 5th power. 2 fraction first. Then put 2 to the 5th power over 5. And we're getting 17.06 repeated, or 256 over 55. Because 256 over 5 units cubed. That is it. My numbers are wrong. It's calculation error, but the process is correct for sure. All right, that finished that question. Wow, one question left. One question left. So now we go. Question left. So, back to my number. I'm gonna go all out for 20 minutes so far. I know people easy, you know. We're working for about 1 minute. That is a 2 or 4 minutes paper. So we're working this paper straight, but I finished already. This question says the probability of A is 0.8, probability of B is 0.5, probability of the union is 0.9, and we're to calculate this probability of B given that A has occurred. Probability of B given. So this thing that I want right here is actually equal to probability of B intersect A, B intersect A, Mr. Shaw. B intersect A over the probability of A. So how much of B is in A? So that's the same ones. Let's work out what this is first. You can get it from this relationship. Remember, probability of, and this is same as A intersect B, right? Probability of A intersect B. The same as this. It's equal to the probability of A plus the probability of B minus the probability of the union. But this can be over here and this over here. Those two can treat places. I'll put another way. Sum of this and this always be equal to the sum of these two. Right? So this works out to 0.8 plus 0.5 minus 0.9. That becomes what? That becomes 0.4. Because this and this is equal to 0.1, it becomes 0.4. That's 0.4 probability of intersection. So this thing now becomes equal to 24 probability of B, given that A has occurred, which is equal to probability of B intersect A or A intersect B, same over the probability of A becomes equal to 0.4 over probability of A is 0.8 is equal to half. Other fraction 0.5. So I mean that these are independent events. That's probability of A given that B of other third is still equal to probability of B. So they are independent events. They asked that. Nope. Those are independent events, for sure. Right. So okay, I'm gonna note right here. So say since probability of B that B has occurred is equal to the probability of B that A and B are independent events. Another way is that the probability of A intersect B must be equal to the probability of A and the probability of B. Let's see if that works as well. Let's put this part in there. So also, they didn't ask for this, but I'm not still doing it. I could have asked them to determine if it is, if they are independent or not. So that's the other way. Should have been independent. This is true. So the intersection is 0.4. See, this is 0.4. This is 0.4. Equal probability of A is 0.8 times the probability of B, 0.5, which is true. What is that? All right, that's half of 0.2. Half of 0.8 is 0.5, 0.4. That's another proof. All right, that's why they're independent. Anyway, next question. Next question says, my last question, 6. Next question says, kinematics and proof. Kinematics. Question says, a pair blue dice. That's each number 1, 3, 5, 7, 9, 11. Those are odd numbers on its face. Second pair dice, red pair dice. Second pair red dice has each of the numbers 2, 4, 6, 8, 10, 20. Those are the even numbers on its face. Dice is rolled. The dice are rolled simultaneously, and the sum of the numbers on the face that record the sum. So record the sum of these values and these values. All right. It says complete the possibility space, which is a sample space. Right. Possibility space here below by inserting the sum of 2 dice for each row. So basically adding up these numbers. So like how this plus this equals this one, right? Adding up the numbers. So it is 2 plus 3 is 5. Then 2 plus 5 is 7. Then 2 plus 7 is 9. And 2 plus 9 is 11. So you keep adding 2. 2 plus 11 is 13. Then 4 now. 4 plus 1 is 5. Then 4 plus 3 is 7. So what I mean is that these numbers coming up here, same numbers. You're gonna have 9 next, and 11, then 13, then 15. Yes, 4 plus 11 is 15. And it continues, right? Plus 6, and this is 7. So these numbers coming up here. So that's the one, the 7, 9, 11, 13. 9, 11, 13, 15, we have 17, 6, 11, 17. And this come up here now. So we're gonna have 9, 11, 13, 15, 17, and 19 plus 8 and that 19. Then this come up here now. It's gonna be 11, 13, 15, 17, 19, 21. And this come up here. The last number is 22. So let's see if it matches. 13, 15, 17, 19, 21, and 23 is coming. That's a sample space completed. That's an easy. This part says the probability that the sum of the scores of 200 dice is a prime number. The question is how many prime numbers are there? How many prime numbers are there? So all the numbers are odd numbers. Only prime number is 2. We're talking about this sample space here now. Careful. This is the sample space here. That's where you want the values from. How many values are we talking about? 1, 2, 3, 4, 5, 6 this way by 1, 2, 3. Oh, come on. By 1, 2, 3, 4, 5, 6 this way. 36 sample space. 36 is by 6. 36, right? I could take this way. 6 up here. 6 up here. 1, 2, 3, 4, 5, 6. 6 on 1, 2, 3, 4, 5, 6. So there are 36 possibilities. 36 total. That's sample space. Then I want the prime numbers. So the prime numbers. The first prime number is 3. And 5. And the 7's up here. Well, like most of the numbers not prime. So we can find the probability of the ones that are not prime and subtract that from 1. That's one way to do it. So the probability of not prime. What are the not prime? So these numbers are not prime. Circle them in purple. So let's do not prime. Probability of not prime equals. So these are not prime. So these are not prime. One that are not prime. 9. 9 not prime. 4 there. And then the next non-prime number is 15. Is red or it shouldn't better. This is red. Non-prime. So as I said, non-prime is 9. 15 is not prime. Not prime. 17. 21 is not prime. Those are not prime. How many of them, bro? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 not prime. 11. So probability of not prime is 11 over 36. 11 over 36 is not prime. So therefore, the probability of prime just to show probability of a number being prime becomes 1 minus 11 over 36. This one is 36 over 36. 36 minus 11 is 25. So that's 25 over 36. What we could do now, since the number that prime, not prime is 11, the number that not prime is 25. So we can do that way as well. So that's same thing, same. So we say prime is 11. I'm not prime is 11. Therefore, probability of prime and the number set up. Number that is prime 11. Therefore, number not prime equals 11. Just to show better than that. So you can see the number not prime is 11. Therefore, number prime is 36 minus 11, which is 25. I just got to count the prime, and not prime, because there's more prime there. Right? We go to one, if you want to count the 25 prime still. Right? So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and it's down here, 25. So we have more to them as well. 25. I need to get this 25 over 36. It's probably a bit of a problem. The probability of getting an even number. No, there are no even numbers in there. Because what happened there, adding even numbers and odd numbers. If you add an even number and an odd number, you're going to get an odd number. So those are all odd numbers there. So probability of getting an odd even number, probability of even 0, because there's none of them there. Next one says, calculate the interquartile range of the data represented testimony diagram. So one interquartile range. So we need the Q3 interquartile range. Remember, is Q3 minus Q1. So we need the Q3 and the Q1. So we need to see how many values are there first. So we can break it up into two, top half and bottom half. Find Q1 as well. So how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 values. So I want to break it up 10, 10. All right. And then the median will be 2 millivalues. Let's just check it one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We'll divide 10 and 10 first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first 10 stops at this second 6, right? So it's at the bottom half. The top half is up here. All right, and these will be a 2 millivalues if you want the median. These two. You have to average those two if you want the median. You have 2 values in the middle. All right, but now we want the position of the first quarter. Now it's the halfway mark of the bottom 10. All right, so it's the 2 millivalues of 10. So the fifth and the sixth one, right? 1, 2, 3, 4, 5. These are the 2 in the middle. So having these 2 values. Okay, so you have 4 that way and 4 the other way. We're including this, put this color in blue. So we don't be confused. These 2 average dividend. Yeah, those are 2 in the middle. Oh, no one. Let me take it now. But these 2 in here give you a Q1. I'll put the Q1 and that's Q1. It's the average of those 2. All right, and then now the top half, say first half 4, that's the fifth value. All right, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So 2 millivalues here now are these 2. These 2. The same value that is a Q3. Those 2 give a Q3. So with a formula method as well, you know, and do this, and say it's a 20 values, right? N equals 20 in this data. N equals 20. We could say the position of Q1 is 1 quarter of 20 plus 1. 1 quarter of 21. 1 quarter of 21 is 5.25, which will be the average of the fifth and the sixth. Right? That will be the Q1. And then similarly, we could say the position of Q3 is 3 quarters of the 20 n plus 1 term. 3 quarters of 21. So that would be 15.75, which would be the average of the 15 and the 16 over 2. That would be your Q3. So quantity, that's what you're going to get. So that's 10, 11, 12, 13, 14, 15, and 16. And then the bottom half is the 5 and the 6. 1, 2, 3, 4, 5, 6. We could have divided up like that as I did before without doing all this calculation. I'm not showing you. We could do that way as well. In any case, the Q1 is on this. So if it all Q1 from the average. Remember now, this is actually 42. 42 plus, and this is actually 44 over 2. That's going to become 43 for sure. And the Q3 is actually 67. Because the 2 value is 67. 67 plus 67 over 2 becomes 67. Therefore, for the interquartile range comes Q3 minus Q1, 67 minus 43, which works out to be 24. But the unit of measure is, I don't give any unit of measure. It was centimeters, that was centimeters. Whatever unit of measure the data was in, that's what we have to do, but I didn't give anything. That is it, 24. All right, gone fast. Next question. Next question says, figure 3 shows a box and whisker plot which represents a set of record data. All right, remember in this box and whisker plot is a quartile. This is Q1, this is Q2, this is Q3, this is the highest value, this is the lowest value in the data. All right, it says state the median. So the median is the value right here. That don't look like halfway, because that don't look like halfway between 25 and 30. All right, look like a bit more, like this is about halfway. So, 25 and 30, we're talking about 27.5. Look a little bit more to the right of the middle. I'm going to say it's 28. Right in the middle is about 27.5 right here. It's about 27.5 right here. So right on that, I'm going to say it's 28. And then don't put any unit of measure either. So determine the range. The range is the largest value minus the smallest value. Now the smallest value is 10. This largest value here is about 74. It's not 75, about 74. So it's 75 it. This is clear. So I'm going to say the highest minus the lowest. That's 74 minus 10 equal to 64. Down here now says describe the shape of the distribution. So it is skewed to the right, as this on the right is longer, and the one on the left, and also the box on the right. So when skewed to the right, it is positive skew. Positive skew. So when I say the distribution is positive skew. Positive skewed. And say skew to the right. Right skewed. So say right skewed. And what that means is that the half of the data, remember, median divide the data half and half. Notice the range of the data, or the data in the second half is more widely spread than the data in the first half. So the top 50%, the data in the top 50% is more widely spread than the bottom 50%. The median is basically within the portion of half of the data. All right, so let's say describe it. So let's say the top half of the data is more widely spread than the bottom half. What's the answer? So the first second 50% of the data is more widely spread than the first 50% of the data. All right, that is that. Next question. Next question says, it's kind of not so clear. It says, this is the word 5. This is 5. 5 out of 30. This is out of. Not clear, but that is 5 out of 30. 5 out of 30. Students in a class were randomly selected and their heights recorded in centimeters. So these are the heights in centimeters. These are the students, A, B, C, and D. So they took a sample out of a class. So the whole population of a class is 30. We're taking a sample. Right, so this is sample statistics, not population statistics. And it says calculate the variance. It is variance. Calculate the variance of their height. Centimeters. Square that. Oh, because variance, the formula for variance is on the thing. Remember, variance is the square of standard deviation. So, actually, this is variance. Either this formula or this formula. Oh, the simplified version of this formula, which is my preferred formula to use, is it is the sum of the x squared, sum of the scores, over this is a number of scores, minus the mean score squared. That's the variance equals that. If you want the standard deviation, then you would drop the square and put the square root over that. This variance I want, so that is it. It's going to be a squared dimension, so it's a squared meters. I will find the standard deviation to be in centimeters, squared, centimeters squared. This formula I'm going to copy down to use. As I said, I could use either one. All right, this is for samples. Sample data, sample statistics, and population statistics. Good. So I'm going to be using this formula. And you see those values so well. So we need to calculate the components of this, right? So the first one is the mean. So the mean is the sum of the values divided by the number of values. That's what the mean is. So and then this we're going to square the values as well. So let's put in an x squared so we can maybe get it and square them and add them up, right? And get the calculator. There's another formula. We calculate the mean and then take the difference and square it. It's another formula, but I'm going to just use this one. Anyway, you're going to do some calculations, right? So 135 squared. So that is 18. You could actually put these in the calculator and work it out, you know. So put all of them in the calculator, so rather than do 1. And so we can actually just beat you because we don't have to waste time. So we can just set the sum of x squared. Look at the calculator. So we can set the sum. Okay, so sum of x squared. Sum of x squared equals the square them and add them up. So the 135 squared plus 144 squared plus 137 squared plus 146 squared plus this is that it's like 153. The print is bad, guys. The print is bad. I'm gonna assume it's 153. 153 squared. I'm working this as 153, 146, 137, 146, 4, 135. That's what I'm using. All right. So define volume using the current processor. So that's some of the square of those 5 volumes 1, 0, 2, 4, 55. And the mean knows some of the value divided by the number of values. So the mean X bar for some of the values, right? For the sum is this is right for the sum is over 5. There are 5 values. So sum them now. So it's 135 plus 144 plus 137 plus 146 plus 143. That's the numbers. So that's 7-1. Looks like a nice one plus 5. 715. We're doing 715 divided by 5. So we have 143. 143. All right, so those values coming out nicely. We'll drop in these in this formula now, and we will get our answer. So it's equal to so the sum of x squared is 1, 0, 2, 4, 5, 5, 4, 5 minus 143 squared. 143 squared. That's going to give us our answer. Let's just do that. 102 455 over 5 minus 143 squared. 42 squared. 42. 42. And that is centimeters squared. So if you want a standard deviation of a square root this, you can write it down. Standard deviation. Standard deviation. Equal to the square root of 42, which should be square root of 42. So didn't ask me, I'm just doing this, which was 6.48 centimeters. Just extra. I didn't ask for this. If they wanted that. This right is the answer there. All right, end of this test. And that is that. Is that. All right, I'm going to share this in the class group. You guys can have a look at it. All right, this was a nice easy thing, but this was really a very easy thing. If you have got any question on it that was challenging, it's really easy thing. All right, no sugar on this paper. Nothing on this paper. Should have been presented properly. All right, the only thing that they use over English, they should have used the word compound. That's the only problem with this one. Apart from this was really a nice paper, but it should go well. All right, that is it. That is it. You want it, if you say I made a mistake, let me know. Let me know if you see any mistake. Send me a message or put it in the chat. Say a mistake. That is that. All right, I'm going to end it now. Bye, everybody. See you on the paper ones. See you on the multiple choice. Bye.